Okay, let's do the output. Let's do the reactions first, the base, because you have to put in Excel and then show it to the engineers to see what they are, and then we'll do the joint followed by the beam displacement, link forces, and then the member DCR. So we'll open back up our our SAP file, the two-story frame that we created. Hopefully we didn't. So we saved it. Woo. Okay, let's take a look at the no numbers and what we want to extract.
How about the distance from north to north? Yeah, we assume 24158.
DC divided by 2, half a column depth,
No,
plus 2.75. So yeah, that distance. When we look back to the introduction to nonlinear analysis, before we had at the back of what the dimensions were for those.
Yeah.
Okay, so this is half of the column depth. The x distance is DC divided by 2 plus 2.75 to the center of the hole. Okay, so that's what it is. This one is the dB plus the thickness of length. So that's it. That's the model for those nodes. So that should be same as here. Now let's get the reactions here. We have 45, 8, and 1, right? So I'm going to start out another spreadsheet. So hopefully this time we know how to remember how to reference it. Okay, that's the SAP open. We had that before. I'm going to open up a new sheet. So blank one, and I'm going to save as it's going to be a macro workbook. Yep. SAP output. Okay, let's save that one. I'm going to call this, we name it base reactions. Okay, and this one is joint displacement. Okay, and then come here, link forces. Okay, and what else? We got link forces, member forces, and then member DCR. Okay, so I'll say design DCR. Okay, so go back to our Visual Basic again. I'm going to close out the other one, so you don't need this, and go back to Visual Basic, SAP output, one story template. I'll leave it on. Again, for this one, we could do it within the workbook if you want. I'll just do it outside, easier. So we call this one SAP output. Okay. Remember, first thing to reference it first, so they won't remember. Okay. And I think somehow it just says V12, even if you have two versions installed. Remember, and let's say that works or not. Yep, SAP 12. I think that's the version. See, it says both of them says V12. One of them's got to be V14. So, so we'll see what it is. So yeah, first step, make your references first. Okay. Now after that, you could go get the output, and I'll go to show you the. Yeah, let's do it here first. We want reactions. Okay, base reaction, joint reaction. Okay, so this is base reaction, that's the command. Okay, and some of the parameters are lowercase, step type, step number, FY, FZ, MZ. So these are some coordinates we don't really use. So all you're looking at is now base reaction. Okay, return equals to SAP base reaction number, close out SAP. Okay, so we need to define the number result, low cases, step type, step number, and you go through each one of these. Okay, low case, this is an array. Remember, this is an array, so it's more than just one number. It's got to be, you could include iterations for like 60 or whatever array, and then the total number of results returned by the program is the number of results. Okay, so let's see how we handled it previously on the template. So the template, what I had done was I separated the two, PR and SR, so output. Okay, output PR. So open up SAP, I ran it before, get base reactions. Okay. So let me copy all these for now, and I'll go through you line by line, you guys. Cut and they paste it into the new spreadsheet and get sub reactions. That's okay. Right, get base reactions. Base reactions, okay. Dimensions, elements, step type, step number, F1, F2, M2, M3. Okay, so first of all is I'm saying this, if you have selected anything previously, then I'm deselecting all the cases. Okay, this one, I don't know what combo names I have, so I'm trying to get the name list and then put it into the number of names and low cases. And now from here, combo output selection 0 to number of names -1, and then I'm returning the low cases. Okay, so I'm getting all the low cases. So for B3, I'm returning the value to B3. So if you look at this sheet, mine is B3. So I have to go specify what sheet next. So when you say this one, SAP reactions, right? I didn't name this one SAP reactions. I just named it base reactions. So let's go change that a little bit. So base reactions. Okay. Let me show you another thing in here. Is you could call cut and paste or replace, find and replace. So find, replace that. I just want to do reactions. Okay, base reactions. Replace, 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 replace. Okay, replace. Okay, that's one thing. Instead of having to go in and type it again, I just find and replace it. So it's easy. That's one of the programming things. Okay, my first one is B3. That's cell B3. What element I'm returning? What joint? Number 1. Joint 1. Okay. Next one is joint 8. Okay. So I have 2.
45.
Right now 1, 8, and let's do 45 as well. Okay. So 45. I'm just gonna exactly copy and paste. I need to define where I'm gonna put it first. So instead of G3, we're gonna put more out here. So this one was B first, G, right? So B, G, and we'll do it in M. It's supposed to be L. We'll just leave it. So either one. So make it M. 3. Okay, so now the note is 45. Right? So note, this one's when you go look at joint reactions. This is actually, I'm using joint reaction, not base reaction. Sorry. So there's other ways to output it. Let's say it's joint reactions. I'm actually using a joint reaction on output, so that's slightly different than the base reactions. So joint reactions, if you look at it here, the name, dock this one. Okay, dock this one. Let's do this one. So we have the first one is name of an existing point. Okay, that's name of an existing point. This one is 1. Okay, so the first one is 1. is it a element or object? So we'll say that's from an element. Okay. Number results, it's the same number results, we didn't change anything. And then yes, object, element. These are what you could return: lowercase, step type, step number. Step type and step number is when you're doing really iterate any kind of iteration, so any nonlinear analysis, then you got the step type and step number. For us, we don't really have that. You don't really need it. And then following it, you get F1, F2, F3, M1, M2, and M3. Okay, so here's what we're asking for to output. So F1, F2, M1, M2. So we should not see any M's for the any number under the M. So because we pinned it. Okay. So let me set up the top one again to look at what was the previously output. We're saying we want to do the set reactions. I set it up this way previously. You can see base reactions. I'm going to copy the whole thing here and then put it on your sheet as well. Base reactions. So we're returning low combos. I did not do. I would just copy and place previously. So you can see all these are black. You don't have to change anything. Okay. The whatever color blue here is, I'm actually have pink in my screen output. It's like I say, the output for that one is not very good. So the first output should be node, combo, F1 is shear, F2, F3. Okay, so that's the first group of output that we should see. Okay, so let's go back to the Visual Basic, see what we're asking it to output. So first one is element ID, lowercase, F1, F2, F3. Okay, starting at 3. Alright, let's see if this works. Okay, 64, element, something I probably did not define again. Oh, I don't have any outputs yet. I have not run the file. So look at that first, and probably you should run the file before you try to output anything. Okay. Run all. Is it locked or not? Not responding. Okay, so maybe I do have something already. Okay, so I do have some numbers here. Remember what these are, we'll get there next time. You see, these are very strange. The set divided into 1 member, 2 member, 3 member, and 4 members. So in each one of these nodes, they have a little tilde in front, which we don't really know before. Okay, 6 and then tilde 25. They subdivide those for you. So I did not ask for those. So when we get to the member forces, these comes into play. Where to specify it. So now, what the heck is not outputting? Saving this one, and let's get smart, make sure we did have a reference. I might try the other one. That's what we get for installing 2 with the same one, huh? So that should be, that's version 12. Huh. Other one too. Well, let's see if this works. If not, then I'll go and debug it again somehow. So do I have element, number results, element, lowercase. Lowercase is string. So I should have. We saw the error before, remember? It must be my reference is not to the right set. And I can't even touch anything right now. It is still running. So let's go back to, okay, and can't create object, that's right. So most likely is my wrong reference in the set. Let's not do this one. Let's do the other one, set 2000. Oh yeah, see this? I can't see it. That says 14. That's how that, but it says 12. Okay, so I guess you could go and browse for it if you want.
Yeah.
To go directly to that. I didn't see this little hidden, so it is that one. So that's why we're getting the message. Okay. Okay. Should not give me the message. Oh, hold on. Maybe some stupid mistake that I'm here. Base reactions.
We change the zone.
It's called base reaction.
Yeah.
Okay, they don't. Yeah, all the time we don't get recognized. As I saw that one as must be. Yeah. Base reactions. Okay, so base reactions. Good. There's base reactions. Okay, so here's all the combos. I want to make sure you guys are comfortable with it. No, again, I'm going to copy this across. Right. So I skipped one because I started M. Yeah. Remember? Let's get rid of all we have done here. I am not going to start with that. I'm going to start with L3. Okay. So for formatting, you might want to separate it into two because I don't think you could fit all one into one sheet. So we'll see what that is. So yeah, now all we're trying to do is this. So that you should be seeing the node first, and when you come back in, it'll start with that. Okay, so these are the set base reactions. So this is what you need to send to the engineer to check. So the no obviously is not 1.0, you know, it's 1, kind of confusing. And then no 45 is this, no 8. So let's check it now. For us, very easy to check is this. Well, let's do the cases. Axial 7 is the seismic. So you look at 7. So 12.96 should be no 1. And let's display the 7 or E, either one is just the same. Okay, negative 12.965, negative 12.9647, blah blah blah, along one, and then the shear is negative 8.06. If you look at this one, notice the reaction on this one. on the center column, no axial load, very little axial load, because we're taking compression, tension, compression, tension, 0. However, it's seeing a lot of shear, because you're taking should be 1.5 times or close to 2 times, somewhere between the two, between the outside and the between the exterior and the interior columns. Okay, so that's you could check that. More shear, 13.9 and 8.06, 8.04. So you should expect to see very little axial, but you have quite a bit of shear. Okay, so that's base reactions. We could output it if you have any kind of nodes. You have more or less, then you could do that. Okay, let's check our joint displacement. Okay, we'll go back and get the joint displacement. So if you look at the here, I can't put. Oh, I can't read it. Oh, JOINT.
Yeah.
Okay. Nope.
Replace this place.
Okay. Get low displacement. Get joint displacement. Okay. We looked at joint reaction before. Now joint displacement. So very same name of an existing point. So what we want is we want our point to be 22 and 10. Okay, so we'll come back to that. So that's the name, and then it's going to be a element, a joint. We'll see what it is. Read through it if you want, and then all the same. Other than the F1, F2, F3, M1, M2, M3 is the same as our joint reaction. Okay. Selection element is where you select it. Group element is where you have it in a group together. Object element and element. I always use the element one. Object element is as a result requesting from the point element. Okay, corresponding to the point object. Specify the name. You want to see what that is. I don't think I used it for this, but so what I did is, you want to open another one. Let's do another one. Insert module. Let's call this one. Name it to joint displacement. Okay. Again, make sure we have our tool references. Reference 14. Okay, so I'm on the right. Well, the subs should be the same as my other ones. So we'll go back to our template, and here you see, I'm asking if there should be just one displacement. Now we want two point displacements, right? So minor modification is required, but it should not be much. So phase reaction and joint displacement. Set base reaction. Okay, joint displacement. All these definition or dimension dim is to define what it is. We saw that again. Deselect all combos for output. Get the list of. I need this because I'm looping through the combos. Okay, you could take a look at what their easy one is for the output. So joint displacement, if they want to do all group elements, they have a group that's group element. Number of result objects, loads, all these are same. Okay, the only thing you have to specify is the first two. If it is all, then you're grouping it all in the group, and everything else output is the same. So that's that's the displacement from their example. So for ours, I'm selecting the combos from 1 to 64, and then again return value is A3, and my no is previously was 3. Now we want, do you want the first floor first or second floor? Let's do 10, right? Okay. This one is object element, and then number results, and then F3 we have, well actually we have 10 here already. Let's do, I had the frame one side on either no before. I took an average. So now I'm going to just take the center one. Okay. Previously, when I had one story, I took one here, one there, and then when I looked at it, I just took an average. So for now, we just take the center one, so I don't even have to rewrite it again. I just change the number. So 22, right?
22.
Yeah, I can't see. It's taking some time to think. So 22. Okay. So displacement. Let's take a look at what we have for E. That should be 0.8122. Okay. So now, since all these set drift, remember, it's gonna crash because my no is not set drift. I am putting it in joint displacement. Okay, so I'm going to rename, I'm going to copy, and then I don't really need to rename it. I'm just saying that this should be joint displacement. So again, let's go find and replace drift with joint displacement. Replace, you can replace all, but I just want to make sure I pick up the ones. Okay. And the reason I did the copy and paste is so it's copying exactly. If I misspelled it, I'm copying whatever, not like last time, missing an S. Okay. So now this should be able to do joint displacement. Run it. So I'll go to the joint displacement is here. Okay, 10 and 22. Let's see what's on the top. For the one template, I call it set drift. I have the 2 here. Okay. Something you guys should know is when we check the drifts, right? Or win. Some combos are not win, some combos are seismic, right? We output all these here for combinations here, right? When we're checking the win and seismic, here's what the what I'm checking. So I'm going to copy this over so you guys could know what's what. So when we're checking dead, live, all these are what combos. Okay, so that is the win combination. We're checking for drift for wind. Okay, for seismic, we're only checking these 2. Okay, so let's. Right now, this one is taking it as an average. That's what I did before. Right? That's not right. So we should say seismic first story. Seismic second. Okay. Remember, now let's win first, win second as well. I'm gonna do that. So you get all the displacement. So for seismic, I am just gonna take this one. I don't need to take take an average of this. Just that. Okay. So that's just coming from there, and the second one is just this one, right? So this is not drift yet. Remember, we were saying drift is the relative difference between the two. So let's do a drift first E drift, I guess 1, E drift 2. E drift is this one minus the base. Base is 0. Okay. This one minus the first. That's our drift. Okay. So that is the drift. So what I am taking for seismic equals absolute. You should do max. You could min so for seismic I only have 4 fields to worry about. Maximum of these 4. I'm just being lazy, I'll drag everything down, but it should be that, break it, that's your 4. Okay. Min is the same thing, so okay, so equals the maximum of the absolute of this one and absolute of the second one. Okay, that's our first floor drift. And second floor, these numbers will be the same. Okay, so let's do H1, H2. Okay, that's what's H1. H1, we'll just take it from that one. That would be 109.2. Yeah, actually this one you could use the floor height. We're assuming because of the long beam there's not much deflection between, in terms of, let me explain this one. It might be easier to pick. This one we're doing, you have the nailer on top, you have the beam, you have the bottom, okay, you have the center line, that's what we model it, okay. I just read this distance to the bottom, okay. I could have potentially picked this one for the drift, because the shear deformation between this long beam is very little. And then when people compare drift, they typically take it to the floor line. No, to floor height, yeah, roof height or the floor height. So what this one is not quite the roof, not quite the floor. So if somebody gives you H1 or H2, then just use H1 and H2. So when I say 104.9, it's probably a little higher. Let's say 115, okay, because have the beam depth, no depth. Okay, H2, I don't know what it is, I'm putting the same number. So that's just for you guys to know which ones we're checking. So I'll finish up the delta allow equals 0.025 hx, okay, so that's delta, okay, I'm going to say equal to this times that, okay, so that would be my delta 1 allow, delta 2 allow, I flipped it to delta 2 allow is, I'm going to use the same, and typically when they give you the numbers, they only give you one number, so you assume it for both the same for the first and the second floor. So that's 0.025. So we'll do this one, drag down again, and these are inch. Okay, this is delta m. Now for your set output, I'm comparing that now. R equals to 8. I'm going to say, okay, I'll change it up a little bit. C sub D equals to 5.5.
8.
Yeah, 8, right? Yeah. C sub D equals 5.5. So my delta M. This is very same. I want to call it delta U. Okay, we have delta S and delta U. So delta 1 U, delta 2 U. It's just how you name it. So I'm just separating the delta M. Delta M is actually delta allow. I didn't want to say it. So this one is our first floor times C sub D, okay, equals to second floor times C sub D, okay, inch, and check equals to if this one is less than or equal to this, then okay, now it's no good. Okay, so copy down again and make sure that's the same fields we're talking about. Okay, so for drift is good. Remember we say we use a 6 before, 6.5, and then use a 4.4. Look at the difference in terms of that. You know what? I'm going to do a DCR or drift so it's a little bit more evident on this one. So this is the DCR. This is equal to that divided by that, right? So that's 0.7. That you can see how close you come to it. If you use a 8, the DCR is 7.728, which you have to find 0.5. My DCR is 9. So using a bigger 8, you also have to use it. When your force is going to reduce, but when you check the drift, it's going to increase. That's the same thing. So that's how they get you. And now, if right, if this one is
it's in fact back to the drift.
That's the one. And now you can say 1.01 or 1.02, whatever you're comfortable with, going over a little bit. Okay, for string design, I think our members are 1.03. For everything else, it's close to 1.01. So, okay. So these two are okay. So that's SEP drift check, SEP base reaction check.
The displacement we just check for one joint of this floor on the joint.
If you have a one bay, depends on how you apply the load. Remember, if you apply the load uniformly, you get the same on both sides. If I only apply the load on one joint, and then when you're looking at just one bay, one story, then you should take the two and then just average it, because it's going to be very close. For us, the drift, if you look at the definition, it should be the center of your structure. Okay, so since this one, we do have a center one, we'll just take it at the center. Where we don't have a center one, I mean, you're supposed to take it like there. I don't want to add a no, so I just took an average of the two. Okay, so this, we took the no here and took the no here, assuming it is the center of the structure. Okay, so that's the drift.
And we check the value of combo fit.
Yeah, combo.
Some combo.
$55, $56, and then $59, $60. If we look at it here, okay, these are earthquake combinations.
So it will govern.
It will govern the earthquake. Remember, drift is only for earthquake check.
Yeah.
Okay, for wind, sometimes people want to limit the deflection to something, and the engineer will specify that. But we, we don't really. Not many people have a number for that. Mostly. Yeah. Okay. So for again, here is the same thing. For my wind drift, I am doing these combinations. Okay. So for wind, I have my wind 1. I'm supposed to be equals to wind 1, and shouldn't be anything, right? It shouldn't be. It should be the x1. I didn't have any wind load, so you shouldn't have anything. Wind 2, it should be u1 as well, which I don't have anything, which is very little. Okay. Now wind drift, I have to do the same thing. I want to finish it up. Might as well just to if I have a this is if somebody would ask you to do any I want to limit my deflection in the frame for wind load of a certain amount, then this is where you do it. Okay. Okay. So these are for your deflection input. So I'll give you this sheet as well, so when you guys go back step output, you have the base reaction, you have the joint displacement. Now let's go to the link forces. Okay, so drift is pretty much done. So let's make sure we're getting same number out, and hopefully we are. For 55 it should be 0.468 for both the 59 as well. So if you look at drift 55, the bottom one should be 0.468. Okay, 0.468, and now the top one is 0.812. So looking at our number, 0.468, 0.812. Okay, so that's drift is doing right. All right, next one is link forces. Again, we'll go back into our VBA to try to extract it, and again we'll insert another module. Okay, I'll call this one link forces. Okay, so sub. Oh, I don't need to do that. I have a link forces one. Again, here is the PR connection out. Get member forces. I'll skip that one first. I'll come back to that. Link forces. This one is a little bit more involved because of the number of links now have gone up. Right? So if you look at this, it doesn't matter private sub or sub for us. We have link 1, get link forces link 2, link 3, and link 4. Right? So now when you look at the link ID, we have obviously added a lot more link to it than our previous output. So if you want to rename your links or anything, then you could. Remember we showed previously we could rename the links. So we have 1, 2, 3, 4, 5, 6, 7, 8, all the way to 15, 16. Okay, so previously I had just a couple of links to do that. You could probably write a loop to loop through the number of links output. Right now I have 4, so it wasn't that big of a deal. I just say 4 links, and this still works. Okay, just to see if this one works before we modify it, let's update this stuff. Okay, I did not want anything else. I only wanted the axial. I mean, this is how much output you could get from all these step type object, low cases, elements. I highlighted which ones I don't want to get. So the offset is 0, 1, 2. When you jump to this one, when you disable it, I just start again at 3. So A3, and let's look at what sheet we want to put it. We call link forces. And then copy this one to the or this one here. So it's link forces. Again, we'll do our, if you highlight over it, then when you say copy, replace, it automatically knows it on top, so you don't have to type it in. Control V, link forces, so replace. It replaces all the ones, even the ones highlighted. You'll comment out. Okay. So link forces. Let's just run it this way without adding the other links. Okay. We'll come back. We could do it at the other links. So this should, after we run it, we should get link forces for the 4 links here. And let's go back. Right. Every time it's gonna give me link forces. Okay. Do I have that link forces? Nope.
S.
Yeah, what happened to the S? I put it in. Save it. There you go, link forces. Okay, here are the link forces. So we have link 1, link 2, link 3, link 4. So we could output all the links, and what we do with it later is to look at the link axial. Okay, let's use this one as a check. Remember, we have to check if the link forces are less than 0.9 Fy of the link. So that's a step we need to check. So let me make it look a little prettier with the link forces output on the top here, and I'll show you what I am doing there. Okay. You can't see it here that evident, but when you go back to this sheet, our design combos for the link design are 36 to 60, right? We output it all here. I just want to see output it here. So for our analysis to check it, we should only be looking at this to 60, right?
36
to 60.
Why just these combo?
This is the LRFD combos. So if not the omega combos or pushover combos.
36 to 60.
Yeah.
Now why the 1 to 35 is not complete?
ASD, allowable stress design. Yeah. So if you look back at our LCM, these are the low cases. These are the ASD combos. These are RFD combos, and LRFD combos are 36 to 60. Okay, but that's what it is.
So why we need the ASD combo?
We need it for the base reaction, for the foundation design.
Why?
Because the soils engineer, they still give you allowable stress. So the bearing pressure, 2 KSI, 2 KSF, 3 KS, 4 KSF, those are still in the allowable stress.
Yeah. FC they provide.
FC is for design. What I'm talking about, when you're doing the foundation design, when you're doing your bearing pressure check, we don't do it. The engineer do it.
Yeah.
Those ones are ASD combos. Okay, they only use ASD combos. So for the reactions, if you want to look at our reactions, no, we output both the ASD, which to 36, so 35. These we give it to them so they could do their foundation design, bearing pressure check. These we give it to them so they could do their concrete LRFD design. So when we're doing like a footing check, okay, this check shear and bending in concrete, these are LRFD. So when you're doing check, moment, and shear, these are LRFD. When you go to the bearing pressure, allow,
for the footing,
that's ASD. Okay, for foundation design, that's ASD.
If the moment frame locate on the podium, so it will be with the LRFD.
Yeah, we let them do whatever they want. That's why we're outputting all the combos. You could do whatever you want. Okay, as long as your output package shows them what it is. Yeah. So that's why when we go to tomorrow, when I'm gonna go do a practice one or show you guys what a package looks like, we would always include the low combos and the base combos and low combos for them. Okay, so I don't have the package here right now. I have it on the network drive, but when we get to there tomorrow, I'll show you the package, the calculation package content, or you say column-based reaction. That's an Excel spreadsheet. We also need the loading and geometry models as well as LCM that we define it for. Okay, so this is kind of a list of package what we need to show tomorrow. Okay, so we cover beam displacement, base reaction, link forces. I'll finish out link forces right now. What we need to do with the link forces. Okay.
And the base plates and anchor. We will also use the LRFD, omega.
Yep, that's right. So when you come to the base plate design, the spreadsheet that I had here is when you go to the base plate design. Now you know where my reactions are coming from. Okay, the reactions here, all of them, all the way to the omega 5. Okay, this one I linked it previously to a certain template. So what you could do actually is, if you have an output already, like what we did for the output, the base reaction. Too bad I have more than one joint now. I have mine base plate. Remember, it's set up for left column and right column. You could set it up for one column as well. We could modify that and just set up to one column, and then depends on which column it is, and just loop it through. So you don't have to re-copy it. So that's what we get the base reactions for. Base plate design, anchors design, as well as foundation design. So that's why the base reactions are critical. Joint displacement is for drift check. Okay, drift check, basically that's it. Joint displacement. We don't really care about anything else on that, and this is confirmed the frame is stiff enough to be able to take it. Link forces, we want our link forces to remain elastic, right? That's one check. So what we here is we are going to look at the combos that we're designing for. So 1 through 35, I don't care about. Okay, and 1 through 36 is what it is. So look at the link for you. Let me see. The link will give you two forces. I forgot. Node 4 and node 7. So if you look at the link 1, and it should be the same, right? It's just an axial load through the member. So if we look at link 1, this joint is 4. That joint is 7. So when you look at the output that we just did for the link axial, link 4 and link node 4 and node 7, even though this is link 1. Okay, same thing. Node link 2 is node 2 and 5. So if we look at this one, scroll across, actually here, node 2 and node 5. So for these ones, you could typically it should be the same number, right? So but the combos we look at is up to 35. I mean, not look at is up to 35, so we don't have to worry about that. I'm gonna gray it out. So on mine, I could see gray out. On yours, I don't know. It doesn't do anything. Okay, and maybe it does. Here we go. So I don't look at those. Okay, 36, 60. I don't look at these. Okay. Again, now I'm gonna look at max, min. Equals maximum equals minimum. It should be very symmetric if you look at the two. Somewhat. See this one 41.45, 42. Because one combo we're pushing one. Well, actually, one combo we're pushing one direction, another combo we're pushing the other direction. If you're loading is symmetric, it should be symmetric numbers. If you're loading for like dead loads offset, then it could be different from these ones. So for what we have done right now is pretty symmetric. Okay, so that's that. Maximum of absolute of this one, absolute of the minimum, and we're calling it, that's one of the numbers, and I'm just gonna copy it to compare to the different node. Okay, different links. Okay, so now you know each one of these, and we're gonna check if links yielded during for all design, for all LRFD design combos. So that will be 36 to 60. Okay. For what is our PY link? Right. This is just the ASF times FY of the link. Or AS is just the yield. Yep, times thickness, stem, times FY of 50. Okay, so let's say I'm going to put in PY link of not PY link, W. Okay, this equals to 2, let's say, or whatever we used before. Okay, now my PY link is equals to times 0.5 times 50. Okay, is that right? Yeah, and phi PY link this should be kips. This is that one times 0.9. Okay, 45. We are very close to. We just say I just picked the number. Okay, so you say here you put it in DCR equals to this one divided by that, and 142. I'm gonna say lock it. So right, control I'm going to say DCR 1.03 is okay, right?
Yeah.
Then you check which one's over.
1.5.
Ah,
1.
equal to. That's actually, what is that? D 1.5 greater than, no.
Okay, no.
Greater than is no good.
Okay.
Less than is okay.
Okay.
Yeah, so I just flipped it. Okay, so that's okay. So one that comes out, we say this one's no good. Okay, so what do? Upsize the link. Go back and change that to 2.125. Run it again and see if that's okay or not. Right? If it's okay, run it again. That's changing the link. Yeah. So if it's still no good, I'll just go 2.5.
Yeah.
Make sure you get it bigger. Right? That's how you adjust the link, and this is the iteration.
Yeah.
Remember, every time you change this, you have to rerun it again.
Yeah.
Your stiffness change.
Yeah.
You see how many iterations this is gonna go if you don't start off with a good one per se. So okay, 2.5. We'll say at the end we'll go back and run it.
Run in SAP instead.
Yeah. Yes. In SAP, if you don't get it, you have to iterate again. Okay. So iteration require update SAP 2000 model each time. Okay, so that's link output. Okay, we're getting warmer. Link forces, member forces. Beam displacement. Beam displacement, we want it for actually both the SS model and the PR model. So I'm going to say member, no, what is it here? I don't have a beam displacement here yet. Yeah. I'll add that to the end. First of all is simply support it. The second one is PR connections. Okay, so I'll need the two. This is our step 2 that's required, and this is a basic beam deflection check we need to get.
Yeah.
Okay, so first of all, let's get after that. Get the design member forces. Member forces. Let's jump into this one now. When we looked at the member forces previously, where was it? I have to see the labels or joints. Display one of the moments or something to get our to get these intermediate nodes to show up. Okay. The reason we have to get that is, let me close out all the other stuff. The base plate design output. We'll have this one. This is a template. Beam forces is very strange. Why do we need it, or when do we need it for the beam forces? Remember, when we're doing one of the design steps, we need to find the shear in the beam, or we want to do our axial force in the beam, moment in the beam for what the actual design moment is. So if you output this one graphically, you could see this okay. Okay, but what they output, they show it as one element here. Okay, but your output, you have to ask for, I want to ask for certain element, and the elements between these two number, because they automatically subdivide it for you, 4 elements. So when I have to do the beam output, what they output for that beam is the object, element, combo, F1, F2, F3, F3. Okay, object is previously my 9, and there's the beam reaction, 9 left, 9 right. Oh, 9 1, sorry, 9 1, 9 4. The left element, if this one element is 9, let's go to look at element name. Here, see, 9 1, 9 2, 9 3, 9 4. Even though we did not ask for it that way, they subdivided into it. Okay, we want the reaction on this side. We want the reaction on this side for our axial check and for the shear check. Okay, now how do I get those? So I have to get the reaction for element 9 1. I have to get the reaction for element 9 4. So that's what this one, element 9 1, element 9 4. And then when they output it, they have different stations for you. First, left, right. So the right one is really reaction at here. I'm not interested in reaction here. I'm interested in reaction here. So I have to do some manipulation in Excel to get that to work. Okay. So what I did is actually I added these in myself. Left, I say combine all these together. I want, that's the left, that's the right. Okay, 9 1, 9 4, 9 4, 9 5. So what I want is I want this number left. Okay, and for the right, I want these numbers. Okay. So these numbers and these numbers for that combo. So if you look at combo 1, let's display it for combo 1. Well, this one is very small because I need to update the link. So moment. Oh, sorry. We're looking at a different file. that's why it's not comparing. That's just like, what the heck am I looking at? Yeah. So this is a combo 1, and this one is even for a deflected shape file, right? Remember, we have to define our link. This should be a very small number right now. Yeah, 4.5. So this is for for SS connection. Okay. For getting output for that, well, let's change it for now. Display, define, sections, link. And again, right now we're using one link for everything. Okay, 4500, somewhere in the range. Okay, we are using one link for all these links. You're gonna have to model them different. We prefer one link for one beam. So these 4 should be the same. These 4 should be the same. But when you go to the next level, definitely these links should not be so much bigger. The higher you go, the smaller your moment it's going to become. So these could be smaller links. So in the template for the two-story one right now, let me save this first. Okay, for the two-story template, I have two different links assigned, and that's the reason. When you go up, you will need two different links. When we go to our SAP two-story template, it's going to convert. When you look at it, I have two different links. Okay, link 1, link 2. Okay, link 1 is on the bottom. I need to look at the sections. Link property. So this should be link 1. Okay, NL1. And then when you go up to the top, link 2. Okay, if you have the same span like what we have on this design example, the base spans are pretty much the same. Like 22 is the same width as the 42. Then the links could be the same. But if this one's really wide and this one's really small, then you might even want to switch it in between those two. So now we're thinking about connections for that beam only. Okay, then that's when you modify the link. So you have to go and name it to be something different. Link 1, link 2. You know, we call this one NL link 1, and then you do another, add another one, add new property, NL link 2, blah blah blah. That's what you add another one, and do that. So this one is somehow doesn't let you copy it. You want it to copy and modify something. Okay. So how do you do that in here? You could do it by hand, copy. Also, I think I have that as part of the VBA as well for doing a generating the link. So when you go into PR, I kind of skip over that part when we looked at it the first time. You're saying updating the load. Must be updating here. Updating the link property. So you could generate your links. If you have two of them, just copy it and make it two, and then do that. So that's to generate your link property. Okay. All right, enough said. Now let's go back and we want to extract the beam reactions, right? That's what we're talking about, beam reactions. Okay, I have beam reactions. We get beam reactions, and then set output. I have member forces, and we call them the same, beam reactions. So I don't. All right. Copy. Okay. Right now, I am only doing the middle two beam. I mean, this beam here. That's why it doesn't look too much. I think is element 9, 9.1, 9.4. Right. If you want to do this beam, let's do 32 as well. I think. So let's copy that up. And we'll figure out where to return it later. So 9.1, 9.4 is done, and then 32. 1, 32, 4. Okay, my reactions, I'm writing it to it really out to somewhere already. So let's see why I did that. Okay, the reason I did writing it out so much is because I have to do some manipulation with the numbers first. So I'm gonna start another one at probably, well, maybe we should do one tab for one beam, right? That might be easier. Beam 1 reaction, beam 2 reaction. Then when you try to calculate the end reactions, it wouldn't be. You could just read it from here, because right now I have one beam is very easy to set up. If you have many more beams, then it's a little harder for you to do all these calculations and try to set up. And you're gonna have to scroll all the way to the right. So let's set it up a slightly different, maybe even a different spreadsheet. It's a set beam reactions, right? How about that? Let's do that. Set output, because the beams are so much involved. Okay, so I'm going to delete all these. That's why the beam deflections or a beam reaction is a little bit involved, because you don't have that. So beam 1, beam 2, beam 3, beam 4. Okay, let's stop it here now, and then we'll go in. Instead of having me to modify what we just did, 9.1, 9.2, I'm going to do it to just do 1. Okay, and you're going to go back and beam reactions and run it again and change that if you want. Okay, so beam reaction, instead of that, I'll do beam 1. Okay, so beam 1, I am going to get this one, or however you want to call it. You want to call it beam 9?
Exactly.
Yeah. So let's change it to call beam 9. We'll call this one we'll do a couple of them this time only. Beam 32. Go back to R. How about this is cool. Okay. Again, since it's a new sheet, I want to make sure that our references are correct. Keep 14 is okay. So, and do we have it open? Yes. Is it run? Can I get a? No, I don't have it run. You could have it built in the macro to check if it's run or not. If not, then give you a warning. Please run model or run model. If it's not run, then run it, kind of thing. Okay, so
tired.
Yeah. So you could get it a little bit more fancier to do that. Okay, so that's done. And when we look at the macro, go back to here. Where is this one? Beam 9, right? Beam 9 macro, beam 9. It should be ready to go. Nothing else need to be changed. Okay. So what I did is I'll put things to here. Okay. What I don't have similarly before set up is I'm gonna copy this down and starting from N and copy this down. My location. Location is what I put in myself, so I know what this is. Okay. Okay, 264. Okay, and that's another one again. Oh. And I'll show you what I'm doing to get left and right. Okay, so this is set up is save. The Visual Basic is done. It's outputted all this to you. Okay, so for what you need to do from Visual Basic, there's nothing else you need from it. The output is done just by pushing the button. You get the beam 9. Let me modify this and then copy it over, because it's a little easier to just do it once and then copy over many times. Okay, so we have not set it up. So the next one is I'm just showing concatenation. Okay, I'll just copy the 2, label this one. Okay, and let it go down. Okay. Again, copy these 2, let it go down. Okay, label. So we're done there. Now set up to extract it out. Okay, I have something hidden right now. Okay, for these combo, I'll make it all here. I'll start from A. Okay, I want the left location. I'm reading this one in. This is a VLOOKUP from these. Okay, that's how I'm able to get my reactions in. This is left, that's what that is. Right, this is a VLOOKUP from this one, 9 that's right, and the range somehow is not coming across. Oh, sorry. Remember, this is called 9.1. This is 9.4. I did not put it in right. And in my thing is red, so you could tell what's required. Okay, so here. This, I don't need to do these. I hide it. That's why I'm hiding it. I don't need to see the location. I'm hiding it. But these are the calculations, and it automatically calculates it for you. Red, which I see it on mine, and then all of them are okay. Okay, so let's check. My axial is negative 1.7. This is the row I want. Well, let's do a LCM combo 7. 7 is better. It's easier to see. This is the row I want to see, and the right is this is the row I want to see. Okay, so better be when I do LCM 7 left, this is what I want to see. Right, this is what I want to see. 129.5. Okay, Now let's look at this again under LCM 7. Okay. The red is, the diagram should not look like that. Okay, the moment diagram, yellow and red.
Yeah.
The red doesn't show up. That's why I say what. Yeah, red becomes black. That's why it is like. Okay, so you want it to be left side. Okay, 769.2. We want 7. This is a template one. I know I'm not looking at a template one. We want to output beam reaction. 69.2. Okay, that's the moment. That's the moment on 79.5. If you look at that side, scroll over 729.5. So, and then the shear is 7.75. Shear is 7.75. 7.75. Axial is 1.94. Okay. So omega low combo axial is what we actually were concerned with later, but now if you look at all these, this is the axial low, the certain combos shear, and also for your axial low 61 axial min. This is for the connection design axial omega combo moment from omega combo. We have to check with the MPR. Remember, not this one. We have to check with the MPR for making sure we're designing the beam to apply the MCR there. This is what we do with the template to make sure that we are designing for the MPR. So that was the little adjustment I made over the weekend for our templates. So we check the beam for the holes, to check the beam for the MPR. So if we look at the one-story template, which is going to come up, I have added those checks into our step. So this is the beam hole check, this is the column hole check, and this is the MPR check. MB max, this is where I need the MB of the beam to come in. So this one MPR is that we're designing for that. Okay, so I don't need to adjust it anymore because we're designing for bigger MPR. Okay, so that's basically beam reaction check. Okay, I'm going to delete this one, and I'm going to say copy, make a copy, and we want to be 32, right? So we want 32 and 32.1 and 32.4. So again, this is easy to modify since I'm just going to give it a reaction. I'll delete all these first now to make sure it's filling up. All we have to do is go back to our Visual Basic, and then I don't need this one. We move. No. We move. No. We move. No. And I'm going to insert a module, and I'm going to call this one beam 32. Okay. So copy, paste, and everything down here I'm going to refer to okay, done. This sheet is done and referring to a different sheet. I don't need to modify anything else. So all I have to do is run this one, and it will populate our beam 32 sheet. Okay, so we just saw that happen. Populate the beam 32 sheet, and also did all your calculations for here. So make sure it's correct. 5.4 5.46. These looks like it didn't do much jump from the beam 32, and because the numbers is going to be pretty close, right? Let's do another beam on the top that's going to be a little different. Beam 22. So again, copy, paste, beam 22, and going back into our did I delete the beam 9? No. Insert 22. Okay, so Control A, Control C, beam 22. Again, all we're looking for is updating anything that referencing that sheet to beam 22. Replace. I could just replace all for this one. Okay, so we did that one on this one. Okay, now let's go and make sure we're getting the numbers on this 22. I'm going to delete all was outputted before, and same thing as this side, so make sure we are getting what we're getting. Beam 22 reaction, go. Okay, that's it. Beam 22 reactions. So, okay, these are, oh shoot, no wonder they're not the same, I'm sorry. Remember what we have to change? Each one of these, I was looking at why the same number. Beam 32, okay? Beam 32, all the numbers I'm looking at is the same. Why is that the same? Beam 22.
Yes.
Beam 22.
For the name.
Yep. For the element that we want output. So beam 22. That should be done. What happened to it? I must just dump something wrong. Yeah, because that's beam 22. I have named these beam 9. We need to modify it 22. And you could make it a little bit more flexible by putting the name up somewhere, but I'm just lazy right now. I'm gonna finish it. So that's beam 22. Okay. Beam 22, location, values. What am I doing? I don't need a location on this one. Okay, so that's beam 22. Same thing when we do change it. I'll change it now. Is object 9, object 9. So it should be automatically changing. So let's go to beam 32. Finish this one for you, and then we'll call it. We'll stop it and come back. Okay, so the beam output is done. Okay, beam 32 is 32 here, object 32, we got 32 here. But again, these are not correct. And what I'm saying is we should not hard code the first one. I'm just gonna say equal to this one should be equals to the left, right? So 31. So whatever you change, you don't have to worry about it. This one I hard coded before. Equals to 32.4. Okay, so now this is being a little more flexible. and you get it. This time all your change should come across and without having to find. So the moments should be a lot less, and if you look at this one, see this one, 1565 versus the bottom beam 2193 versus this one 2313. So all of them are different. So now we know that for the 3 different beams. So for all the different beams here, I did not do 3, 4. I'm going to delete it. You guys have to go in and modify what input you want to put for these different beams. Okay, and then if someone wants to see the beam reaction like an engineer, then if you want to give them a table, summarized table, then you could do view, page break. I just want to show these here, okay, and set print area. So you have the 2 low combinations that goes from 36 to 60, and I want to set it up to show the top 2. So now you're going to see horizontal, and then print preview. You should be able to see all the reactions for, let's say I would put beam something on the top, LCM, axial, left end, right end, then you see what the axial moment, shear moment, all that stuff. This should be axial moment and shear on top. Okay, so that's what we have, and I think we're done for the beam end forces, and let's take a break. So member forces, or I call beam reaction. We're done. Beam displacement and a member DCRD. This one is really easy. This one's gonna same as a beam reaction, but you have to pick the node, which node you want to take. So that's the result. Okay, so let me stop recording if I'm even doing any recording, and